Hello everyone, I'm Yuhan. I'm a fifth-year PhD student from Cornell University. Today I'll be talking about ShadowSense, detecting human touch in a social robot using shadow image classification. Let's begin with some background. Just like human-human interactions, touch is an important modality when interacting with robots. Despite that, not so many robots have integrated touch as an interaction modality. This is possibly due to that the existing robot tactile sensing use force or capacitive sensor arrays, which require a large number of sensors to achieve a useful spatial resolution. For example, the huggable robot used more than 1,000 sensors to achieve full body detection. A child robot CV2 used nearly 200 sensors. Another shortcoming is that force-sensitive arrays require a relatively flat and stiff surface and are insensitive to light touches. The capacitive sensors are more sensitive, but they are vulnerable to environmental interference. There are some sensing alternatives with lighter hardware such as acoustic sensing and air pressure sensing, but they can only detect with low spatial resolution. Given this existing gap in HRI, our goal is to develop a low-tech, low-cost touch sensing alternative for social robots. In this work, we introduce ShadowSense, where we put the camera inside a robot's body to capture the shadows created by touching its skin. We think of ShadowSense as a modality between vision and touch, where it brings the high resolution, low cost of vision sensing to the close-up sensory experience of touch. It outperforms the traditional sensing arrays by achieving a higher resolution and gaining the ability to detect both on-skin and over-the-skin activities. The core interaction capabilities of ShadowSense include detecting touch activity, classifying touch gestures, and identifying the position of the touch event. A range of gestures with varied scales can be sensed, from detecting a small fingertip touch to a human-sized full-body hug. We implement ShadowSense with an inflatable robotic prototype. It has translucent skin cover up the body and the fisheye camera inside, capturing both the shadows on top and sides of the skin. To detect and classify shadow images, we implemented densely connected convolutional neural networks that takes input of shadow images and output and predicted label of touch gestures, where you can see on the top left corner of the video. To check the touch positions, we present a color segmentation-based algorithm to check both touch positions and the overall shadow positions. We then quantitatively evaluated the performance of gesture classification algorithm. We collected a total of 6,000 shadow images, capturing 6 different interaction gestures, including hug the robot, touch with the palm, point, punch, touch with 2 hands, and not touch. We collected them under 3 lighting conditions, daylight, dusk, and night, and we then split them to training and testing dataset, where we trained the network with training dataset and evaluated the accuracy on the test set. Here shows the result of the test accuracy and the confusion matrix, separately reported for each lighting condition. It has the highest accuracy, 96% under daylight, 92% under dusk, and 87% under night. Overall, it can distinguish between the 6 gestures with relatively high accuracy, but is negatively affected with dimmer lighting condition. This video shows a few potential HRI applications. With ShadowSense, you can easily turn an object into a touch-sensitive device with the simple addition of a camera, even just a balloon. ShadowSense can be implemented on an inflatable guide robot, where the robot could respond to various touch gestures and make movements accordingly. Together with an internal projector, ShadowSense becomes an interactive touch screen for inflatable soft robots. Another use case for ShadowSense is to provide a privacy-preserving shield for camera-based home interaction. When a robot entering a personal space, having a camera can pose risks to the user's privacy. By physically covering the robot's eyes with a translucent material, a robot can still make use of some interaction data in the form of users' shadows instead of their high-fidelity images, like inferring what the user is doing without collecting their actual appearance. To summarize, ShadowSense is a vision-based touch sensing method for social robots and has many benefits compared to the existing sensitive skin arrays. It can detect higher spatial resolution with minimal hardware cost. It can operate on different types of skins, no matter curved, soft, or deformable, and it expands the detection range to detect gestures above the skin. For more information, please refer to our paper. That's the end of my presentation. I would like to thank my advisor, Professor Guy Hoffman, and my colleagues to perform this work with me, and the NSF for funding this research. Thank you all for your attention, and I'll be happy to take any questions.